Hi there. In this video, we're going to be looking at integration of exact differentials. So an exact differential has the form dz is equal to dz dx times dx plus dz dy dy. We want to integrate dz and end up with z. And we saw in the last video, for us to be able to do this, it has to meet a certain test. We have to check if this dz can actually be integrated to begin with. And that check is, we let, firstly, dz dx equal to p, and we let dz dy equal q. And that check was, the derivative of p with respect to y must equal to the derivative of q with respect to x. Once it does meet this test, then this function can be differentiated. So if we just remove this first part of this differential, we just say p dx, right? So this should be z, and this should also be z, because if we add apples and apples, we should get apples, right? So this should be a part of z, and that should also be a part of z. So if you think about z as being p dx, sorry, dz being p dx, then what this means is that z should simply equal to the derivative of, sorry, the integral of p dx. And the same would apply to y. If dz is equal to q dy, then z should also equal to the integral of q dy. So we have two integrals, right? p dx and q dy. And we see that z is equal to both of them. So how do we reconcile this now? Which one is actually z? How do we go about resolving this? We can easily see that they're the same thing. You're looking at an example. So that example is dz is equal to 2xy plus 6x dx plus x squared plus 2y cubed dy. So as before, we let the first term equal to p and the second term equal to q. So p would equal to 2xy plus 6x, and q would equal to x squared plus 2y cubed. So firstly, we check if this thing is an exact differential. So we find the derivative of p with respect to y, and that's just equal to 2x. We can see, yeah, y to the power 1, so we just left with 2x. And then we find the derivative of q with respect to x. So that would just equal to 2x. So we see that they're the same, so therefore we can proceed. So if z is equal to the integral of p dx, well, let's just write that down. Z is equal to the integral of p. P is 2xy plus 6x. 2xy plus 6x dx. And now we integrate this. And when we do that, we see that we get x squared y plus 3x squared. And then if we do the same with y, we say that z is equal to q dy. So q is x squared plus 2y cubed. And we're integrating this with respect to y. And when we do that, we get x squared y plus y to the power 4, and then 4 times something must give us 2. So that's a half. 4 times a half will give us 2. So this is integrated. So there's one other thing that we need to mention here, right? If we look at the original function, since this is a multivariable function, when we differentiate with x, we keep y constant, right? So what we're saying here is that we should have a constant of integration that is somehow a function of y, because if we differentiate y, we get 0, which is exactly what is the case here. And the same must be true here as well. If we differentiate something with respect to x, and y is held constant, or rather we differentiate something with respect to y and x is held constant, it means that if some other function was something of x, it had x in it, it became 0 once we differentiated it. So we need to take that into consideration. So here, when we integrated with respect to x, it means that there was some function maybe of y. There was some function of y, and if we differentiated it, it became 0. So that's why it doesn't appear in the integral. And the same is true here. It means that there was some function that had x in it, and then if we differentiated it with respect to y, then it means that it became 0, and that's why it's not in the integral. So let's look at these two results that we have. We have x squared plus y squared, okay? And then look on the right-hand side, we have x squared plus y squared, so they're the same. Now we need to have some function of y. How do we get this function of y? Well, let's look on the right-hand side. Do we have a function of y? Yes, we do. Half y to the power 4. And then again, looking on the right-hand side, we need a function of x. Do we have a function of x that is only of x? Yes, we do. So what this means is that this g that's a function of y should equal to this function on the right-hand side, this term on the right-hand side that is only a function of y. And in the same way, this function of x should equal to this term on the left-hand side, which is only a function of x. What this means is that z, when we combine it, is equal to x squared plus y squared, that doesn't change, x squared y, plus 3x squared. 3x squared corresponds to this function of x, plus the function of y, which we saw to be a half y to the power 4. So there we go. If we differentiate this and find this differential z, we should end up with our original problem, which was 2xy plus 6x, etc. So you could actually do that and just double check it. So in a nutshell, all we need to do is identify the part of the differential that is p, and then identify the part of the differential that's q, and then integrate p with respect to x, as we've done here, and differentiate it with respect to y, as we've done here. That's with respect to x, and that's with respect to y. And once we do that, we just combine our two results, identifying the functions of x and y, and that will give us our original function z.